Now for testing this boost converter, I will be using my UPS battery 12 volts. Test 1, no load power loss with potentiometer at the minimum. Meter 1 will measure the no load input current and the yellow meter will be measuring the battery voltage, which is 13.32 at the moment. So let's connect the final wires, and so it is 0.02, that is the no load current. That's amazing. Now moving potentiometer to almost maximum, we have 600 milliamperes of current. So that concludes our no load power loss test. Test 2, output voltage measurement at no load. The input voltage is going to be 13 volts from this UPS battery. Okay, keep watching the display of the multimeter. So it is 22 volts. Now let's increase the potentiometer knob for higher output voltage. And now we can see that the maximum output voltage is as high as 66.7 volts DC. Now let's bring it to full. And here we have a maximum of 67.5 volts DC. Now it keeps on showing the output voltage even after I have removed the wire, because this capacitor holds the charge. Practical applications. This is a 24 volts DC motor. And this is the RPM at 12 volts. So testing it with my boost converter. UtSource is a professional electronic component selling website with deliveries all over the world. Components include ICs, modules, RF transistors, etc. You can make order from their app as well. Plus members get 6 to 10% off plus $500 coupon bonus. You see, the RPM is very high this time. Let's make it to full. Oh, extreme RPM. Wow. Moving on to this 100 volts 5 amperes DC motor. Okay, you see, this time the RPM is so high. Whoa! Super high speed. So it is actually running the washing machine motor pretty good. 1 kilowatts. Yeah, and there is negligible heating. You can see I can easily touch it.
Next level. Next level. Next level. Next level. 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 Next level.
The next project is using this brushless fan. Now you have already seen this variable voltage and current power supply that I made in one of my previous videos, and I have been planning on adding this old CPU fan for a long time, and one of my fans also suggested it. So I have finally made this 3D print. So let's complete the installation. Turning on the supply. You see, it looks beautiful. I have this cordless doorbell. It runs on a AA battery and the batteries get discharged really fast, because of which it is very annoying. So let's make it better. Hi, you are watching channel Mr. Electron, and these what you see are a few broken or damaged mobile chargers. So today in this video I'm going to use them to make a 12 volts power supply for charging my batteries. So guys, these are a few 5 volts mobile chargers that I have salvaged. Let's test them. So guys, here as you can see that I'm connecting the mobile charger circuit to my 220 volts home socket power supply. Now let's test it with an incandescent bulb. Although the voltage is not 12 volts from the mobile charger, but still it is glowing. A little dim, but yes, it is glowing. So this one is fine. Now let's test this one. Working. Working. So all of them are working, and now I can connect them all together. Now this what you see is an old dead 12 volts 8 amperes power supply SMPS, and because it's dead, let's open it up, remove the circuit and reuse its case. As you can see, the transformer shows the rating 12 volts 8 amperes. So guys, I've cleaned up the box as much as I could, and after that I also thought about repairing this circuit board which was damaged. So fortunately there was a minor problem. This was the capacitor. You see the top part of it, it seems a little stretched, and you can see that the cover also got stretched, and this was the piece of it that told me that it was 100 microfarad. You see 100 mu f and 450 volts. That's what I took from it. So what I did was, instead of the 450 volts capacitor, I used a 400 volts and 82 microfarad instead of 100 farad. And guess what? That was the only problem, and it started working just fine. Also, I took the capacitor 400 volts and 82 microfarad. You see 82 mu f 400 volts from this slot. And this is another circuit that was lying around, not in use. So let's test this one first. Okay, so let's turn it on and see how this 8 amperes power supply performs. You see the light has started glowing and there is no blast. So here what I have is a bike headlamp bulb. You see 12 volts 35 watts. So let's connect this one first. Yeah, you see it's glowing pretty bright. And here I have full 100 watts bulb, 8 amperes. You see 12 volts 100 to 90 watts. So let's connect this one, and this should be even brighter. Oops, power supply is turned off. Maybe it's not handling this kind of load. Maybe it's old. Let's try by simply switching. Yeah. Oh, it is so hot. Yeah, now it's working. Once again with my lab lights turned off. See, it is so bright. Oh, it's very hot. Now let's also measure the current at the same time. And we did a max of 8.68. Wow, and the supply is working very nice. Now let's test my high current drone motor. Wow, nice. And guys, now that the power supply is working great, I can no longer use the box for my mobile charger 12 volts power supply project, and I will have to use something else for that. So let's place it back as it was before. So guys, now that I have packed it successfully, let's turn it on. And yeah, you see here the red light indicator, it's working now. Car headlamp night eye. Wow, nice. And now for my mobile charger circuits, I'm going to use this PVC case. There were too many stickers on it, so I had to like grind it. Okay, and the case is just fine for my circuits, and these two can go the sideways. Okay, so guys, here as you can see that I've placed all the circuits on the walls of the case, and I've fixed them with screws. You see this one, same for this one, and that one, and it is quite strong. It's not gonna come out. Now let's start with the parallel connection of this side of each circuit, like the 220 volt side that is going to be connected in parallel. So guys, here as you can see that I've completed the soldering part for the 220 volts high voltage side, and here I've used the heat shrink tube for covering it up for safety. Looks quite nice. Now let's connect this cord to the 220 volt socket and see if each individual charger is getting supply. So all of them are getting the 220 volt supply. Now let's connect the outputs together. Now guys, here as you can see that there are 4 power supplies or mobile charger circuits, and because this one and this one, these two are a little weak circuits. I mean, they're going to produce only 1.5 amperes each. So I'm going to connect this one and this one in parallel to increase up or double up the current, and this one is good enough on its own, so is this one. So these two in parallel, and then this set will be connected in series with this one and this one. And you see the bulb is glowing really bright this time because all the chargers are working together to light up one single bulb, and the voltage is quite high, really nice, very bright. And not just that, it can even power up a car headlamp bulb. This is, yeah, here it's written 12 volts 55 watts, so it is quite a strong bulb. You see, it's glowing really bright. Very hot from this side. So let's back it up, take out 2 wires from the box and then cover it up.
Next level. Next level. Next level. Next level. 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 Next level.
Guys, that's the plastic cover that I've just made.
Next level. Next level. Next level. Next level.
So let's check the voltage that it is producing, and here as you can see it's 15.5 volts DC, which is quite high for charging a 12 volts battery. We need around 14.8 volts. So guys, now I'm going to use this 6 amperes diode to create a 0.7 volts drop because the voltage produced by the power supply is 15.5 volts. So 15.5 minus 0.7 will make it 14.8 volts DC, which is best for charging our batteries. So this side of the diode is positive and the silver side or gray side is negative. So the positive side has been connected to the positive white wire, and this one will be connected over here. But before I do that, I will have to connect this metal sheet, which is going to act as a heat sink for the diode. Although the current is not going to be much high, but still there is a possibility that's going to heat up. Although you can do the same process by placing the diode inside the box, but I'm not doing that. So guys, finally the project is complete. Now let's test it with our battery. Now guys, this is the parcel that I got from Loom Solar, which is one of the biggest solar panel manufacturing company in India, along with batteries and their charge controllers. So if you want to have a look at their website, link has been provided provided in the description. So as you can see guys, that it's a 12 volts battery which looks quite similar to a UPS battery. The current rating, as you can see, is 12 ampere hour with an expected lifespan of up to 10 years and 24 months of warranty, making it 2 years. Now the best part about this battery is that it's made of lithium iron phosphate cells, therefore larger lifespan. Now if we have a look at its battery voltage, so as you can see, they have charged it at 13.37 volts. So guys, here I've connected the power supply to this battery, and the multimeter is showing the battery voltage at present because I have not turned on the power supply yet. So when I'm going to turn it on, the voltage on the multimeter should start increasing, indicating that everything is working fine. Okay, so turning it on. So the voltage has started increasing and our battery has also started charging, and it is going to go to a max of 14.8 volts when the charger is going to cut off, indicating full charging. So here we have reached 14 volts and increasing. Super strong. Thrust is too high. The battery is really powerful.